Okay, and we're alive.
Good afternoon and good morning, foam community. We're super excited here on Tuesday, December 17th for this edition of the community call, which is going to feature Jack Zampolin, the director of product at Cosmos, who's going to take it away and tell us a little bit about what Cosmos is, some of their current exciting initiatives, and IBC. So Jack, you want to come on and tell us a little bit about that?
Hey, Jessica, thank you very much for the introduction. And Brian and Katya, thank you guys very much for having me on the community call today. Love working with projects in the Cosmos Tendermint space, and foam. You guys have been building on top of Tendermint for a while, so very happy to come over and chat a little bit more about our roadmap, as well as IBC and kind of what's going on there. So today I'll kind of give a brief overview of what is Cosmos Tendermint. I think most of you probably do have a pretty good understanding of that, but it's the three main products that we make, which are Tendermint, the Cosmos SDK, and IBC. I'll do a little bit of a deep dive into IBC and then talk about roadmap for IBC and then take some questions from there. So just to get started, I was talking about the three layers of our stack here at Tendermint. We make Tendermint, which was our first product, which is what started the company back in 2014. It's a BFT, or Byzantine fault tolerant consensus algorithm, as well as an implementation of that algorithm in Go that's backed by a database. So you can think of it very similar to etcd or Raft if you come from more of a traditional cloud world or any of these other distributed databases. But one of the nice things that BFT consensus gives us is the ability to run nodes on untrusted computers. So what does that mean? Practically what it means is, like, what foam is using it for and what we're using it for over here on the Cosmos Hub is you can run it on the internet with hundreds of your closest friends, and you don't have to worry about your money getting stolen from you. So that's pretty cool. So that's the basis of the company is Tendermint. We still maintain that implementation. It's used for the next piece of our stack, which is the Cosmos SDK. And I always like to describe that as Ruby on Rails for blockchains. So if you're familiar with database frameworks, you can think of things like the LAMP stack back in the day that was backed up by Postgres at the end of it. But there's been a lot of web frameworks that are basically built on top of databases, because developer databases are very complicated. They've got a lot of features around data safety, data replication, and other things. And as a developer, there's a lot of complexity there that if you're building a simple web application, or in our case, a pretty simple blockchain, you don't really need to worry about a whole ton. So what these frameworks have done, like Ruby on Rails or the LAMP stack or some of these other web frameworks throughout history, have done is wrapped a lot of that complexity and given developers a simple way to say, if I get this message, I want to perform this logic. And that's exactly what the Cosmos SDK does. You write which transactions you want your blockchain to accept, and then you write the code for handling those transactions within Tendermint. And Tendermint and the Cosmos SDK kind of takes care of everything else, making it very, very easy to build your own blockchain. In addition, the way that the code is organized is into modules, so that when you're building your own blockchain, you sort of take which modules you want. Let's say you want accounts, you want the ability to do a proof of stake system, and then maybe you want some governance, and then you want to build maybe, something like proof of location with foam, or a random beacon, or some Oracle functionality. You can easily write that into a module and then make that module open source and accessible to other developers who can then build on top of it. So while it doesn't have the same kind of smart contract interoperability that Ethereum does, we do have this ability to do code reuse across these blockchains, as well as now with the addition of a WASM VM, the Cadena VM, an Ethereum VM, and Ethermint, we do have the ability to do these sort of shared smart contracting environments on top of any of these arbitrary Cosmos-based chains. So that's the Cosmos SDK, and we actually built and operate a blockchain called the Cosmos Hub. Well, actually, we don't operate it. 125 validators on the internet do operate that, and we help coordinate and ship software updates for them. But there is a live blockchain that we have built that runs on this system. Foam's another example of a live blockchain on top of Tendermint. Binance Chain, Aragon Chain. There's a number of other folks out there as well. Kava, which is a DeFi platform. There's a number of folks out there starting these things up. So as you can imagine, when we were sort of designing this system, we thought, well, it's great that people can start their own blockchains and that there's tons of them, but if the only way for folks to exchange value across these systems was through centralized exchanges, this is going to kind of defeat the whole purpose. And we're going to end up with these choke points. The government's going to be able to shut this system down just by controlling the exchanges. And we're back to where we were when Mt. Gox got hacked. And pretty much we've got centralized exchanges moving funds between these various blockchains. So one of the things that we designed as part of our protocol was something called IBC, or inter-blockchain communication. If you're living in a world of thousands of blockchains, you want those blockchains to be able to seamlessly transmit value or any other arbitrary information between them. Now, just a sec here. Now, IBC is the protocol that allows that. So if you want to, say, send tokens from the Cosmos Hub, which is the blockchain I was just talking about, over to the Foam chain to stake it as a part of a location staking. Obviously, some rules would need to be changed on Foam chain to allow that, but totally doable. IBC would allow that transfer. Now, how does this work? It's very similar to TCP/IP. So in TCP/IP, if you're familiar with the OSI networking stack, there's the 7 different layers of networking that are required to create a HTTP connection. So down at the bottom, you have sort of hardware and operating system level primitives. Then there's a handshake, and then there's application layer data that's transmitted over the top. And that's what HTTP is. It's an application on top of TCP/IP. So in the same way, IBC, instead of having hardware and machine level and operating system level primitives, has consensus primitives. So as long as you have a consensus algorithm that can roll up to a succinct proof of state, i.e. be able to prove data within the blockchain via a light client proof, and the consensus algorithm has finality, i.e. it's not a proof of work system where there's probabilistic finality, where you need to wait X number of blocks for things to be final. In Tendermint and BFT systems in general, once the validator set, or these are kind of like the miners in proof of work systems, once the validator set agrees on a set of state transitions, those transitions are final and can't be rolled back. So with those 2 primitives, we're able to build this complex layered connection scheme. So with IBC, and let me just walk you through a little slide deck here to kind of show you how the flow works. All right. No, I didn't want to share. I wanted to present. Oh, hey, can you guys still see my screen? Jessica, awesome, great. Okay, all right, so this is basically step-by-step of how an IBC transfer works. And just to describe the various pieces here, a module, when I was talking about the Cosmos SDK, you're saying for all of the proof of location stuff that we do over at Foam, let's say, we have all of that functionality in a module. So let's say you wanted to talk to the proof of location module on another chain, i.e. exchange some proofs. So the proof of location module would initiate the transaction, and you would create a transaction in there that would then be wrapped in an IBC packet. And then once that transaction is created, then it goes through consensus. And this is the same way that you would submit a simple send transaction on that blockchain. And once it goes through consensus, then it's available, there's 2 pieces to an IBC transaction. There's one on chain A and then one on chain B. So we're talking about chain A here, i.e. the source chain where we're sending the transaction from. And then that transaction needs to be relayed over to chain B, i.e. there needs to be a transaction on chain B that says these assets are flowing over. So every IBC transfer consists of one transaction on chain A and one on chain B at the minimum. And once that transaction is accepted into consensus, then a relayer can pick up that transaction and create the transaction on chain B that sends it over. And then once it's gone through consensus, it's included in the blockchain, it gets sent to the IBC module, which then delegates that back to the module where that functionality needs to be carried out, i.e. proof of location. So obviously, as you can see, chains need to not just support IBC, but also support whichever application layer protocol. In this example, we're talking about proof of location, support whichever application layer protocol is specified there. Now, within IBC, these are some more resources that I'll just leave up for a minute. Within IBC, we currently have 2 application layer protocols that have been specified. One is the sending of tokens between chains. And then the other one is the ability for a validator set on one chain to control an account on another chain. So this is like a very complex multi-sig, basically. But we're looking at, sorry, Ryan. Yeah, absolutely. Please shoot.
If you could go back to the other slide, I was just wondering if you could unpack 5, like how the relayer works, like how it's constructed. Is it different in every use case, or is there like a monolithic relayer?
Yeah, that's a great question. Basically, to your answer, there is no monolithic relayer. There's a role within the protocol called a relayer. Now, you can imagine in the most simple case, so just backing up, what does a relayer need to do? It needs to track light clients for each of the chains that it's moving transactions between. So it's a fairly lightweight system, something that you could do in a browser. So let's say as a user, module A over here is on Foam, and module B over here is on the Cosmos Hub, and we're sending tokens. That relayer would basically need to say, like, I need a light client for the Foam network, and I need a light client for the Cosmos Hub network, and then I can perform the 2 transactions required to move chains, to move the data between chains. And if you're thinking about this from a user perspective, this is normally going to be abstracted from them. They're not really going to have to worry about it. You know, you can imagine a JavaScript library that says, I'm going to need to deal with these 2 or 3 chains. I'm going to track light clients in the background. When I need to make a transaction, then the user has one input and I create the transactions on both chains and things happen in the background. UI is updated optimistically. And that's the sort of user experience we can go for there. Now, another way to do this would be to run sort of a server-side process that's listening to a large number of chains and shuffling data automatically between them as it hits the queues. Now, this is more a service that a validator would offer. That's going to have a lot more bells and whistles as far as whitelists and blacklists. There's a lot of functionality required for setting up connections between chains. I was talking about the handshakes. There's actually 2 separate handshakes that each consist of about 7 transactions that are required to create these persistent connections between chains that you can use very few transactions to send things over. So those relayers are more heavy duty and will be kind of sitting on servers and relaying a lot of data between chains. And these would be folks that have sort of industrial use cases for IBC. But in the single user case, it is much more simple. So Ryan, did that answer your question about relayers? Are there any pieces I can dig into there?
I guess just a follow-up question is like, what kind of security guarantees do you need for these relayers? Like, what if there's a relayer passing, false information, things like that?
Relayers can't pass false information because each of the constituent chains that they're dealing with have light clients to the other chains, and data that the relayers are putting in will be proven against those light clients. So the relayers do not custody funds. This is not like ILP. The relayers do not have any ability to steal. The relayers aren't included in the fee calculation at this point. Being able to pay relayers for their services is something that I think we're going to try to work on out of protocol. There's also some current research work on how to do that within protocol. I think the current consensus among the developers that I've talked to is that out of protocol is a better way to do this. So.
Great, thanks.
Yeah, absolutely. Okay, so any other questions for this diagram before I pull it down again?
I think we're good.
Awesome. Cool.
We have a few questions.
Bring them.
Let me.
So, and just a quick reminder, the last piece of my sort of prepared material I have here is talking about the roadmap for IBC. So if you have any IBC roadmap related questions, please just hold those till the end. But anything else, happy to answer now. Tendermint, SDK, or IBC. And thank you, Katya, for grabbing those.
So we have a few in the chat that are more kind of on the Foam Cosmos collaboration.
Yeah.
So one is how soon do you expect the integration you mentioned, and would it be possible to use Atom or other crypto to stake for POL services? Would it be the same service level agreement of sorts?
Okay, so there would be need to do some work on Foam side. I don't know if you guys currently do multi-currency staking for proof of location. Do you?
Not at this time. The kind of
Yeah.
service level agreement contract is specified to be in Foam, but the payments for the location claims can be in any token.
Yeah. I don't think the technical lift there is super high to support staking multiple currencies. So the ability for things to come in via IBC and be staked or on Foam or used for payments, like pretty native to the ecosystem and should not be very difficult. As far as IBC integration, that gets into the IBC roadmap question, which I might as well just go ahead and cover now because I know people are going to be excited about this one. So, we kind of came up with IBC back in 2016. We did our fundraiser back in 2017. And at that point, really kind of started working on it. We had some demo versions that were running that summer. But turns out we had a lot more work to do on the Tendermint and Cosmos SDK side of things at that point. And we didn't really start working on IBC full steam again until we shipped the hub, which was last spring. Last spring, once we shipped the hub, the first thing I did was grab our engineers and say, how do we get this IBC started? So we started a standards process called the ICS process, or Interchain Standards process, to develop a formal specification for IBC in collaboration with a number of community members. I know some folks at Foam have been on these calls, so we've been working with Foam as well as folks from Agoric and a number of other companies within the industry. We've got a number of community calls that are up online if you want to go see who shows up at those and sort of what gets talked about. That spec process ran for about 6 months, and we kind of wrapped it up towards the end of October, early November. And then we had we had 2 actually spec audits scheduled during October and early November that have completed. And the final version of the spec, I think we're on RC5 right now. All of the comments from the various security audits have been incorporated. So I believe we'll be shipping a 1.0 version of that soon. Now, that's the spec process, and that's been going well. We started implementation in parallel with the spec towards the end of the summer. And since we shipped the spec, we've been working almost exclusively on implementation. We've shipped 2 working IBC demos, neither of which I was able to get working today, which I apologize greatly for. I'm going to have to go chat with some folks about that. But if you take a peek on the pull requests in the Cosmos Gaia repo, you should be able to see some there. So that implementation, we've had 1 audit that's been ongoing over the month of December that's helped us find some issues with the sort of base layer of the implementation. Most of the things that we're working on right now are around the implementation of various application layer protocols and how those work within the SDK, and ensuring that all of that stuff is good. We're about 2 weeks overdue for that second demo, which I think we'll get out early in January at this point. And looking at a start for competitive test nets for IBC probably end of January. And that's a competition we're calling Game of Zones. So once Game of Zones is complete and the other implementation audit that we have scheduled for January is complete, I think we will consider IBC 1.0 at that point, and then people will be able to use the implementation to connect. Now, Foam, I know is talking about doing this. As far as the timeline for that, I can't necessarily speak to it, but from our side, we're anticipating the code to be substantially complete for other members of the ecosystem to import and use it starting in February. Hopefully that helps as far as roadmap.
Yeah, no, that's super helpful and quite exciting. We actually had another interesting question from the community as to what is Cosmos most interested in Foam about, and how might the grant project and Haskell help the general ecosystem?
What exactly is the grant project in Haskell?
We've been wrapping up the Haskell-based Cosmos SDK and ABCI.
Oh, cool.
To kind of beyond monolithic options, and also working with Kadena on their Pact Mint project. So their project requires the ABCI in Haskell, which we've built, and that's something we started about midway through the year and is wrapping up this week.
Cool. Yeah. When we're talking about frameworks for building on top of Tendermint, one of the things that I didn't really explain when I was talking about Tendermint is the developer interface for Tendermint is begin block, deliver transaction, and end block. Now, if you're used to saying like database set this key equal to this value, and you're presented with that interface, not great. It's super not easy to reason about. And as a developer to organize your code, it's very difficult. And in fact, here at Cosmos Tendermint, we built 4 separate chains on top of Tendermint before we scrapped all 4 of them and combined those efforts on the Cosmos SDK to make it easier for developers. So tooling like the Haskell SDK to make it easier to build applications on top of Tendermint and other languages absolutely help this ecosystem. And working with folks like Kadena with these kind of best-in-class VMs that they're bringing to the crypto world to include programmable environments on top of these blockchains is something that I'm hugely passionate about. I think as an industry, we're all kind of searching for product market fit. There's a bunch of kind of early folks who are here who are interested, but I think especially in this sort of period of sideways market that we've been in for a little while and looks to continue for a little while, it's very 2014, 2015. And what I'm focused on, and what I think a lot of other folks in the industry are focused on, is not how do we speak to the existing people within the crypto industry, but where are we going to find the next 10x users? And applications like proof of location, things like programmable environments on top of blockchains that can communicate with each other. All of these are these really important primitives that point to really important applications that will run on top of these decentralized networks and will bring in the next 100 million, billion users to the blockchain ecosystem. So a lot of what we're doing right now is a bit of setting the groundwork, but what we do explicitly at Cosmos Tendermint is building infrastructure. Like that's all we do. Like we don't really build applications, but it's folks like Foam sort of pushing the boundaries on the application side as well as the infrastructure side, where we're going to see some really exciting innovation. And I think we'll see a lot more adoption of blockchain technologies as they become easier to use and more useful to us. Does that answer that question?
I think it does perfectly. I think that was very elegantly put.
Thank you.
Do we?
Questions?
These are the questions for now, but community, if you
I have a follow-up question. So a lot of the IBC kind of conversation is around token transfers. And when I was at the Full Node Cosmos offices in October for the IBC meetup, a lot of emphasis was on trying to surface non-token transfer use cases. And in the case of Foam, the location claims that users purchase these attestations, what we call presence claims, they're not actually tokens. They would be logged in this Tendermint radio-based chain and ultimately added to some root chain in some sort of Merkle root structure. And so then the question is, I want to essentially reveal my location claim to some application. And it may be the case that this application actually lives on a different Cosmos zone or on a different blockchain. So can you speak maybe about how these like data transfers will occur that are different than token transfers over IBC?
Yeah, so they happen exactly the same way. And in fact, a token transfer is treated as a data transfer. And between the token transfer spec, the standard specification for application layer protocols and the application and the cross-chain account specification, building additional specifications for specific types of data, exactly like what you're talking about, should be very easy. So just to think about how the token transfer stuff works, let me pull this up here. No, I guess not. When we were looking at that diagram earlier of the data flowing through, this is specific business logic that needs to be performed by each chain on each side. So you saw the module handing it off to IBC. IBC basically hands a bit string off to the module and says, you deal with this however you feel like. And all these application layer protocols do is say modules must deal with the bit strings that come out of IBC, like X. So in the case of token transfers, the sending chain must burn tokens of the given denomination and amount before sending the packets over IBC. And once the packets are received on the destination side, that chain must mint coins of the given denomination and amount on the destination chain. And this operation is atomic, and the only way it happens is if both chains successfully complete the transaction. So in that case, in your case, if you wanted to send proofs of location or some of these other things, you know, those application bytes would be slightly different, and then the processing on each side would be slightly different. And that's up to the application layer developers for this, these various interchain standards. So in the case of Foam, making a proof of location transfer standard would be relatively easy in general. It would be very similar to the token transfer one, similarly. As far as other use cases, one of the ones I'm personally most excited about, which the cross-chain accounts thing kind of gets us to, is the ability for one chain to provide a substantial portion of another chain's validator set and or voting power. Now, this is very similar to the concept of like follower chains, or you know, if you think about the Polkadot and ETH2 architectures with the relay chain and a bunch of follower chains, this would be substantially that, but instead of each of those shards relying distinctly on that chain, you know, there would be an economic relationship between these two chains where the follower chain would essentially pay the root chain to validate the new blocks that come in. This will make it easier for new chains to start up and bind the greater Cosmos Hub ecosystem economically. I think that's really cool. The ability to do cross-chain smart contract calls is kind of low-hanging fruit as well. You know, we've got these Kadena VMs, there's a WASM VM that's out there now, there's Ethermint. You know, each of those would kind of require a separate application layer protocol to deal with the specific smart contracting languages, but calling smart contracts on one chain from another, definitely doable. Really, IBC is a very generic layered connection protocol that you can send whatever kind of data and handle it however you want to on the other side. And the security is guaranteed by the security of each of the chains that's involved in the transaction. Does that make
really
sense?
exciting stuff.
Cool. Any other questions? And I'm sorry, maybe I've got a shorter presentation than some of the other folks that come on.
No, that was great. That was very, very thorough. I think that's all the questions for now. But if like the community is still thinking, you know, we're hanging.
Yeah, I got a few more minutes.
Yeah, anyone has any follow-up questions for Jack, feel free to post them. In the meantime, I'm going to share a few more updates on Foam. So thanks again for joining, Jack. We're really excited about Cosmos here at Foam, and as mentioned, wrapping up our grant work on the ABCI Haskell app.
Oh, can I make one quick note on that, Ryan?
Yeah,
And
sure.
sorry if I'm not as up on some of the grant work as other folks. Cosmos is predominantly made up of two large organizations. One is the Interchain Foundation, which is who you guys are contracted with via grants. They are predominantly giving grants to folks in the ecosystem, as well as working on formal verification of our protocols and doing additional consensus research. And then there's the organization that I work for, which is called Tendermint. And we substantially build the software that makes up the Cosmos network and perform the various activities required to market and deploy said network. So I'm not as much on the grant side. I do review grants occasionally, and I'm very aware of what you guys are working on and extremely excited about it. But I don't have a lot of the details to kind of talk specifically about the grant stuff that I think you guys might have wanted. So just want to apologize for that and kind of explain the reason for that, which is a good separation between the foundation that helps us operate and the company that I work for.
Yeah, no problem. Thanks for clarifying some of the structure of the Cosmos world.
Crypto world, it's weird.
But yeah, thanks again for joining, and we'll see if any more questions come in. In the meantime, I just wanted to share some exciting progress happening with our grant process on the foam map. And we've had a lot of great progress come out recently from two projects, one called Foam Viz, which is a visualization platform for foam data, and the other is a new season of the Block City scavenger hunts, which recently just concluded. So we did the first collaboration with Block Cities about a year ago. It was called the Holiday Treasure Hunt. It was quite successful, and since then they've kind of continued to build out this platform towards a full-fledged game, and really excited to see how that game comes together in 2020. But new things that they released, Block Cities is around adding points to the foam map to win NFTs of real-world locations. And to kind of make this information more integrated, they built a custom foam map snippets page where you can actually render these NFTs in the map, as well as pull data from the Foam API and get additional architectural information about these buildings. So it kind of works as this NFT architectural encyclopedia. And another thing they recently launched for that season 1 is something called the Adventure Map. So this is a standalone map separate from the foam map, where the actual NFTs are then rendered on this map. And when the game is happening, the clues are basically coming by on the side. And there's a game mode where you can explore the shapes of buildings and be able to interact with the protocol from this alternative interface. So it's really great progress to see Block Cities come together with this new platform. Check it out if you haven't already. And we're looking forward to see how this game progresses. The other updates coming from Foam Viz, the links we can share in the chat, or you can find them on our discourse, because you can play around with all these new visualization tools. And they have 3 distinct layers. So the first layer is around exploring the density of points, as well as how many tokens are staked within them. And so you can kind of like look at different areas of the world and get this kind of static view rendering this data, which is based on DeckGL, a tool made by Uber, as well as Mapbox. The second one is called the Journey of the Cartographer, where here you can put in the user address of any Ethereum account that's interacted with Foam. And it basically renders this time-lapse video showing their journey over the map of which points they've added and kind of spatially displaying which areas they've mapped on and overall. So this will play as a video, and you can essentially do that for any user of the protocol. And the third one is pretty cool. It's kind of a holistic view of the foam map. It loads pretty slow right now. It's a lot of data. But essentially here as well, you get a bird's eye view of how the protocol is evolving over time. And you can play basically a video as well and see the points grow and stake or not. And this visualization is quite similar to the one of the Cosmos Hub, which is a really cool one you guys have over there. And so we'll share the links for these. They're all available to test and try and are live today. And there is an open GitHub that the team working on this has for any feedback or questions. I know that optimizing it for data load and so it will load faster is a priority, but for now you can try that out, and it'd be great to have any feedback.
This is really cool and way cooler than the visualization we have. We just put random dots on a globe. You guys actually have geolocations on there, so that's pretty snazzy.
Yeah, so this is a really great project, and it will serve as a foundation for future visualizations as well as ones around proof of location when that's live.
Yeah, we're very proud of our Foam grantees. They're obviously doing an incredible job. We actually have another question.
In Saudi Arabia too. Man, you guys got foam people everywhere.
Yeah, it's quite the global project. It looks like the global community has also thought a little bit more about possible questions, Jack. So Paul is wondering, might you say something about the use of computable ontology as part of data transfer? And if common ontologies are shared, does this reduce the need to communicate data structure? How do you want to unmute yourself?
Sorry, computable ontologies. Can you talk to me about that term and what exactly you mean there?
Yeah, I'm curious as well. Paul, do you want to chat in some info about that?
question came from the chat, so we'll wait for a follow-up.
Yeah, cool.
Paul has that, but I'll just continue with some updates. So some of you may have seen earlier this month, or maybe end of November, we posted a large update around the progress of proof of location and kind of information about the new architecture since we did our first demo. That was just end-to-end radios, logging on Tendermint, speaking over Plasma back to the root chain. We're here, we've actually basically elaborated this architecture and are now, in additional to LoRa radios, programming FPGAs and building a full stack software-defined radio protocol with cryptographic primitives and ways to kind of decode radio packets and timestamp them in a manner that exceeds a simple LoRa transceiver. So this is essentially the architecture. Some of you may be familiar with the diagram on the right because that is the diagram of the foam map and the architecture of its front end and back end and how it connects to Ethereum. We're here on the left. We're still using these LoRa transceivers that can calculate the timestamp of each incoming packet and be able to be decoded through this FPGA. And then we have a full software stack that runs this foam location protocol, can be time synchronized with the other zone anchors, and it timestamps these messages as well as runs the localization algorithms on the chip to be able to kind of do this multilateration based off of the time information. And we need a bigger diagram, but on the left, these radios basically form a zone, and the consensus system they use for each zone is Tendermint itself. And the ways that they may connect back to Ethereum or other chains is where our grant work in the Haskell ABCI comes in and future work we're planning to do on IBC. So we'll be sharing more updates about proof of location in 2020 because we're now at this new stage where we are 3D printing these prototype cases with the new lab here and starting to test things outdoors as well as work with different companies on pilot projects. So this is kind of a rooftop view of our office. We're at the new lab in the Brooklyn Navy Yard. And this is where we're installing radios for testing across different roofs. And as we've been working with them, we're kind of picking out which buildings we want to use and where we're planning to be spending our time. So this is a essentially plan map of the Navy Yard where you can imagine the first zones will be, as we already started testing just one-to-one, but we'll have to set up even more as we're producing these modules I just shown a preview of. And there's an amazing number of use cases here in the Navy Yard we're excited to explore, where there's ferries docking here, bus systems, autonomous vehicles being tested, as well as shared bikes. So check out our most recent update on the discourse, and we'll be sharing more updates on that in the near future. Yeah.
Yeah, that was awesome, Ryan. Thanks. Does the community have anything that they'd like to further inquire about based on all the great content of this call?
Yeah, I don't think we have any questions at the moment. We have some discussion happening in the chat. But if you have some final question, please post them. We still have a few minutes to answer them.
I know someone's got one out there that's going to make Ryan sweat. Who's got him?
We got one question. How pricey are the hardware is anticipated to be? From Lef's Megan.
With the off-the-shelf components we're using today, it's definitely like under $200. But we're basically using these off-the-shelf components to build these prototype modules. And as you saw from the preview image, they're quite large. So we would be custom printing these PCBs with the components much smaller, as well as like a fancy designed enclosure. And from there, if we're going to be distributing developer kits, it'll really be a function of how many units are being produced and ordered. But it'll be possible to also generate your own based off those parts and the specification. So definitely something that is substantially cheaper than looking to mine Bitcoin.
I mean, God, if it's $200 with off-the-shelf parts, sounds like you guys could get that down under 100 if you're doing your own PCBs and stuff.
Yeah, presumably, and then kind of exploring any sort of certifications required, or we have some big ambitions of what the enclosure will look like. So that might affect the cost.
When foam antenna?
When foam, what?
When can I get mine?
Hopefully in the first half of next year. But if you want to come by our office, you can test them out.
Next time I'm in New York, I'm going to take you up on that.
Yeah, and Lev was asking the same question about when the hardware will be available for community testing.
We're likely going to roll out a program for early testers, hopefully in the first half of next year. So we'll be updating on that. As you can see from our updates, we're kind of past this research and development phase from the first demo in May to now, and we're basically been deploying them on roofs and really trying to refine the algorithms. It's really now a software project after we've settled on the architecture of the hardware. So we really appreciate everyone's continued interest, and I know everyone's eager to help participate, test the system, so please stay tuned. For those asking what are those specifications, I don't have access to the YouTube to share the link, but on our discourse, which is discourse.foam.space, there is an article explaining this updated architecture around software-defined radios and FPGAs and explaining the components we're using if you want to take a look. Yeah, I think that's all the questions I see at the moment. So thanks everyone for your attention and time joining us today. And thank you, Jack, for sharing more about IBC and the work that you're doing. And we're really looking forward to continue to integrate with the Cosmos ecosystem.
Yeah, absolutely. And I'm looking forward to dragging you guys over to a Cosmos community call here one of these days.
Yeah, we'd love to present on the ground project.
Yeah, awesome. Thank you guys very much, and a cool update. And talk to you all soon.
Thanks so much.
Thank you. Yeah, absolutely.
Thank you, everyone. Bye.